water, baking soda solution. I'm adding single raisins. I'm adding some buttons. I'm adding various pasta shapes. And now we're adding vinegar. I want to get a nice foam, too much of a foam, but it'll work. My splash guard takes care of it, and now I have activity. So I see bubbles rising and bubbles adhering to various shapes, including the raisins. The buttons are floating on the top, and the raisins are going up and down. There's a reason for that. Some of the pasta is not going. Oh, we just had a button sink. So in general, what's happening is the bubbles are adhering to the raisin. Really, they're sticking in the nooks and crannies and crevices, and then additional bubbles are sticking to the first bubbles through hydrogen bonding. The kids don't need to know that. When they have enough bubbles, there are two forces here. There's gravity pulling them back down, and then there's the buoyancy of the bubbles that's lifting them up. So when there are enough bubbles, they rise to the top, and some of the bubbles pop. They do a somersault on the way back down. So it is a gradually lift and sink. Two forces, gravity and buoyancy. Okay, why do the buttons tend to float? They're symmetrical. The raisins are asymmetrical, and therefore when they rise to the top, only the bubbles on the top surface pop and none of the bubbles underneath. So they don't tend to lose their buoyant force underneath. One last piece. For secondary students, this is really Archimedes. So as the bubbles stick to the raisin, they actually increase the total shape of the raisin. For you math teachers, the total volume. And Archimedes tells us that buoyancy is equal to displacement. So the raisins plus the bubbles are taking up more space. Therefore, they have a greater displacement, and therefore their buoyancy is greater. When the buoyancy is equal to the downward force of gravity, then there's lift and the thing floats. When the bubbles pop, then there is less lift, less buoyancy, and they sink again. Why bubbles pop? So the solution is surrounding the gas bubble, the smallest possible shape with the least surface area is a sphere. All the forces are equidistant. When the bubble gets to the top, there's no longer solution on the top. So therefore, the bubble pops. Why do the raisins do somersaults? Raisin, raisin, bubble, bubble. Bubble's lifting. It's going to pop on my right side as I lift. No longer force over here, still lift over here, somersault as we go down.